IIMK BMS-AT, which is the entrance exam for BMS program at IIM Kozhikode, is going to be conducted on 22nd of June 2025. We are coming up with a crash course wherein we will be covering the whole syllabus that is going to be asked in the exam. This crash course is going to have 30 sessions and each session will be delivered to you on this YouTube channel itself daily at 9 pm. After this crash course is done, we will be providing you with the workshops that will definitely help you train for the exam. As of now, we know that the exam is going to have only QA section and VA section. There is no LR section asked in the exam. But the paper pattern of the exam is not known. As soon as we come to know about the paper pattern, we will definitely deliver 3 to 5 mock tests to you guys as well. So make sure that you subscribe to this channel and inform your friends that this course has started and they can benefit from it. And now let us start learning. In this video, we are going to look at the basic concepts of logarithm followed by exam level questions. So the basic concept, let us try to understand the graph of logarithm. Let us try to understand the graph of logarithm. The graph of logarithm is something like this. We know that log of 1 is equal to 0. So this is x, this is log x. Okay. Log of 10. Log of 10 is equal to 1. Log of 10 is equal to 1. And for the values of between 0 to 1, for the values between 0 to 1, the log is negative. Okay. So we have log x and x. So if x is negative, log is not defined. Yeah. As you can see, for negative values of x, log is not defined. For the values between 0 to 1, the log is negative. For log, when x is equal to 1, so log 1 is 0. And for values of x greater than 1, the log is positive. The log is positive. Okay, the log is positive. This is how the graph of log looks. And if you get any value that is negative of log, then it will not be defined. And then finding out the answer for that, for such questions is easy. Log of negative value is not defined. Something like that. Okay. Now, where is the log used? Now, log is used to find out distances between sun and moon and various planets. Okay. Now, till the 10th standard, the log which we have studied is completely different, and now whatever log we are going to study is going to be completely different. So till 10th standard, what we used to do, we used to have a log table. Yes or no? We used to have a log table. And we used to find out the values of log from that log table. Now, in our exams, we don't have to use the log table at all. Okay, we just don't have to use the log table at all. Okay, there are some 10 to 11 formulas. 10 to 11 formulas. We just have to work on those formulas. Okay, we just have to work on those formulas. Okay, so let us try to understand how log works. The basic and most difficult formula for log is a to the power x is equal to b. Then how do I convert it into log? It will be log b to the base a is equal to x. And log b to the base a is equal to x. So this is the basic and most difficult formula. Application of this formula is difficult. Okay. So in our exam, as I told you, there are 10 to 11 formulas or 10 to 11 small applications we'll have to do to solve the question. So now solving those questions will become easy if you understand this basic formula. For example, 10 to the power 2 is equal to 100. So log 100 to the base 10 and a log 100 to the base 10 is equal to, okay, 5 to the power 4 is 625. Then log 625 to the base 5 is equal to 4. Okay, we'll have to understand how to apply this formula. As I told you, our exam is application-based exam. No one is asking you to prove the theorem or prove the formula. Here, they are asking you whether you know the formula, and if you know the formula, can you apply it? This is what they are checking. Now, log of 0 to the base a is not defined. Correct? Log of 1 to the base a is 0. Why? Because if I reverse the formula, what I have, a to the power x is equal to b, right? So a to the power 0, is equal to 1. So anything raised to 0 is equal to 1 only, no? Yes or no? Anything raised to 0 is nothing but 1. Okay, so log of 1 to the base a is equal to 0. We just don't have to understand this mode of conversion. We'll have to understand how to convert a log into your regular equation or expression. Okay. Next is log a to the base a is equal to 1. Yes, it is true, because a to the power x is equal to b. B is what? A. So a to the power 1 is equal to a. So we have this. Log a to the base a is equal to 1. Next, fifth formula which we have is log m to the base a plus log n to the base a is equal to log m into n to the base a. Okay. And log m to the base a minus log n to the base a will be equal to log m divided by n to the base a. M divided by n to the base a. Now for these two formulas to function, the base should be same. For these two formulas to function properly, or for these two formulas to apply, the base should be same in both the terms. Only then we can apply. Next, log a to the base b. Log a to the base b can be written as log a to the base c upon log b to the base c. Okay, we can just simply turn it into this pattern. For example, log 10 to the base 5 can be written as log 10 to the base 2 upon log 5 to the base 2. Okay, we can do it like this. Next, log a to the base b can also be written as 1 upon log b to the base a. Log a to the base b can also be written as log b to the base a. Okay, for example, log 10 to the base 5 can also be written as 1 upon log 5 to the base 10. Next, log m to the power n to the base a is equal to log m to the base a, and this n will come out. Okay, so what we are doing here, this n will come out over here. For example, log 2 cube to the base 10 is nothing but 3 into log 2 to the base 10. Okay, then log m to the base a to the power n, can be written as 1 by n into log m to the base a. Okay, try to understand this. Log m to the base a to the power n. This is what we had. So n we wanted to get out. So n will get out and come here. This n once it comes out, will become 1 by n. This n, once it comes out, becomes 1 by n, and it will be log m to the base a. It will be log m to the base a. Okay, log m to the base a. For example, log 2 to the base 10 to the power 2 can be written as 1 by 2 log 2 to the base 10. Followed by last property which we have is a to the power log m to the base a. A to the power log m to the base a can be written as m. A to the power log m to the base a can be written as m. Very rarely I have seen the use of this property. Okay, but then application of it is easy. Log m to the base a is equal to b. No, what is b? Log m to the base a. Log m to the base a. Okay, so these are the properties of log. You will have to mug it up. Okay, it is not difficult to mug these properties up. Okay, it is easy. If you write it down 2-3 times, it will be built in your mind. Okay, you will remember it for longer duration. Okay, whatever is the process you use to learn something, use that, but you'll have to remember these 10 to 11 properties, of which this property is very important. Once you remember these properties, application of these properties becomes easy. So let us now move towards the application of the property. So what we have, log, first question, log 2401 to the base 343. It is nothing but log 7 to the power 4 into log to the base 7 to the power 3. Now, if I use this property, this n comes out, so this 4 will come out. And if I use this property, this a to the power n, it comes out in this fashion, so 1 by n. So this 3 will come out like this, 4 by 3. And what we have, log 7 to the base 7. So this is 4 by 3 into 1 only, no? Why? Because log 7 to the base 7 is nothing but log a to the base a. So this is 4 by 3. Second question, log 625 to the base 1 by 25, which is log 5 to the power 4 and 5 to the power minus 2. 5 to the power 4 and 5 to the power minus 2. Similarly, this 4 will come out and this minus 2 will come out, and this will become log 5 to the base 5, which is minus 2. 4 upon minus 2 is minus 2 into 1, which is minus 2. Third one, log 1 by 729 to the base 3 is nothing but log 3 to the power minus 6. I know that 1 by 729 is 1 upon 3 to the power 6, which is 3 to the power minus 6 to the base 3. Now minus 6, it comes out, log 3 to the base 3 is minus 6. Why? Because log 3 to the base 3 is nothing but 1. Followed by fourth question, log 64 to the base 0.125. 0.125 is equal to 1 by 8. Okay, 0.125 is 1 by 8. That is 1 upon 2 cube, which is 2 to the power minus 3. So it is log 64 is 2 to the power 6. 64 is 2 to the power 6. 0.125, I have just proven that it is 2 to the power minus 3. So this 6 will come out, this minus 3 will come out, and it will become log 2 to the base 2. Now log 2 to the base 2 is 1. So it is 6 upon minus 3, which is minus 2. And then fifth one, log 32 to the base root 8. What is root 8 now? Root 8 is 8 to the power 1 by 2, which is 2 cube to the power 1 by 2, which is 2 to the power 3 by 2. So this is log 2 to the power 5 to the base 2 to the power 3 by 2, which is log this 5 will come out and only 2 will remain. And this 3 by 2 will come out and only 2 will remain. So what we have 5 upon 3 by 2 into log 2 to the base 2 is 1. So that is 10 by 3. That is 10 by 3. Okay, so these formulas are very much necessary while solving the questions. These formulas are necessary while solving the questions. We'll be needing it. So for this session, for all the questions, we'll be having this formula towards our right. But then in the exam, you're not going to have these formulas. So that is why it is necessary that you remember each and every formula and you learn to apply. So what are they asking us to do? They are asking us to simplify log 5000 minus log 27. So log 5000 minus log, this is the first question we are doing, minus log 27 plus log 9 by 32 plus log 3 by 40. Now we have to find out, we have to simplify it. It is nothing but log 5000. Now log m minus log n is log m upon n, right? So log 5000 minus log 27 is log 5000 by 27. Then plus 9 by 32. So it will be multiplied by 9 by 32 and plus 3 by 40. So then it will be multiplied by 3 by 40 as well, which will become log 5000 into 9 into 3 upon 27 into 32 into 40. So this is 9 3 are 27, this 27 gets cancelled, this 0 gets cancelled, this is 32, this is 125. So we can say that it is simplified like this, log 125 to the base 32. Or we can solve it further. It is log 125 minus log 32, which is log 5 cube minus log 2 to the power 5, which is 3 log 5 minus 5 log 2. 3 log 5 minus 5 log 2. Okay, so this is what we have, or this is how we simplify the logarithm. Now it is not possible to further simplify. That is why we are not doing it. Okay, generally your option might be in this format or it might be in this form. Okay, moving forward, trying to solve the second question. And you are supposed to pause the video, try it yourself, and then move forward. Okay. So what we have, log 3 to the power 4 to the base 1000. Yes or no? This 4 will go here according to this property. So this n will go here and become n to the power n. Minus log 27 is 3 cube to the base 10,000 plus log this 3 will come here and will become 7 cube to the base 1000 minus log 1029. 1029 is 343 into 3. 1029 is 343 into 3 to the base 1000. Okay, now how do we solve it? Log 3 to the power 4 minus 3 to the power 3. So divided by 3 to the power 3 plus 3 to the power 4 is plus 7 to the power 3. So it will be 7 to the power 3 minus 343 by 3. So it will be divided 343 into 3. So this is 7 cube, this is 7 cube, it will get cancelled. Base 1000 is there already. This is 3 to the power 3 into 3 to the power 1. It will cancel with 3 to the power 4. What we have? Log 1 to the base 1000, which is 0 only. Which is 0 only. Next, we have to simplify this. This is very easy. First one, 1 upon log ABCD to the base ABC. 1 upon log ABCD to the base ABC. Using this eighth property, can I reverse it? Yes. And once I reverse it, it will become log ABC to the base ABCD. Again, if I reverse it, it will become log BCD to the base ABCD. Again, if I reverse this, it will become log ACD to the base ABCD. And again, if I reverse it, it will become log ABD to the base ABCD. Okay, now everywhere the base is same. So what I'll have log ABCD and this ABC, ABCD, ACD, ABD will get multiplied using this fifth property. So it will be ABC into BCD into ACD into ABD, which is log ABCD cube, ABCD's cube to the base ABCD. And we have A 3 times. Similarly, we have B 3 times. We also have C 3 times and D 3 times. Okay. So this 3 will come here and using this property, ninth property, this n will come out. So this 3 will come here and it will become 3 log ABCD to the base ABCD, which is 3 only, which is 3 only. Moving forward, let us try to solve the second question. Second question. 1 upon 1 plus log C to the base AB. Can I write it like this? 1 upon log AB to the base AB plus log C to the base AB. Yes or no? I can write it like this because 1 is nothing but log A to the base A is nothing but 1. So log AB to the base AB is nothing but 1. Similarly, I can write this as well, log BC to the base BC plus log A to the base BC. Then this is 1 upon 1. Instead of 1, what we will write? Log AC to the base AC plus log B to the base AC plus log B to the base AC. Now this is nothing but 1 upon log ABC to the base AB. This is nothing but log. I don't know why, because we are using this property, fifth property. Log m plus log n is log m into n. So log AB plus log C is log ABC. This will also become ABC, A into B into C, ABC to the base BC. And this will also become log ABC to the base AC. Now I can reverse it like this. No, where it is eighth property, like the eighth property, I can reverse it as well. So if I reverse it, it will become log ABC to the base, in fact, log AB to the base ABC plus log BC to the base ABC plus log AC to the base ABC. Again, the base is same, so I can write log ABC. And what I'll have? AB into BC into AC, which is log ABC whole square to the base ABC. This 2 will come out and will become log ABC to the base ABC. Now log ABC to the base ABC is 1. So this is the final answer is 2. This is equal to 2. This is how you need to simplify the questions. Now find the values of this. We have to find out the value of log 5. Base is 5. Then log base is 4. Here we have log base is 3 and this is 81. Now I can write 81 as 3 to the power 4. I can write 81 as 3 to the power 4. So this is 3 to the power 4. So this 4 will come out and log 3 to the base 3 is 1. So this will be log 5 base log 4 base 4. Now log 4 to the base, because this 3 to the power 3 is nothing but 3 to the base 3 is nothing but 1. And this 4 has come out. Now this is nothing but log 4 to the base 4 is 1, and we have 1 to the base 5, which is nothing but 0. This was your first question, which is nothing but 0. Similarly, if I have to solve this, what I have, log 3, then we have log 8, then we have log 27, then we have log 81, and this is 3 to the power 2916. Instead of 81, can I write 3 to the power 4? Yes, I can write. Can I write 3 to the power 4? Yes, this will be 3 to the power 4. Now this 2916 will come out, and this 4 will also come out, right? This 2916 will come out like this, and this 4 will come in the denominator. So what we have, log 3, this is log 8, this is log 27, and 2916 upon 4. Now 2916 upon 4, we will have to do 2916 divided by 4. So 7s are 28, 11, 2s are 8, and then 36, 729. So what we have, 729 log, this is base 3, this is log base 8, this is log 27, this is equal to 729. 729 is nothing but 27 square, no? 729 is nothing but 27 square. So now this 2 will come out, this 2 will come out, and we'll be left with log 27 to the base 27, which is 1. So what I have now, log base is 3, this is log, this is 2, and instead of 8, I am writing 2 cube. Instead of 8, I am writing 2 cube. And this log 27 to the base 27 is 1. So this is log. This 3 will come out, will become 1 by 3. This is 3. And log 2 to the base 2 is nothing but 1. Now this can be written as log 3 to the power minus 1 to the base 3, which is minus 1 coming out. Log 3 to the base 3, which is minus 1. Which is minus 1. Okay. So overall value for this expression is minus 1. Okay. Moving forward, we have to simplify this. This is very easy. What will happen? This a to the power a to the power a to the power a will come out. It will come out here, and a to the power a, 1, 2, 3, 4, 5. A to the power a to the power a to the power a to the power a. And we'll be left with log a to the base a, which is 1. Now, these 4 will come out here, and it will become a to the power a to the power a to the power a. Okay, and this log a to the base a will become 1. Then this a to the power a to the power a will come out, a to the power a to the power a will come out, and this log a to the base power a to the base a will be 1. Now this a to the power a will come out, and it will be log a to the base a, which is 1. So overall answer is a to the power a. Overall answer is a to the power a. Okay. Overall answer is a to the power a. Now try to understand the next question. Okay, how to simplify this? We have under root of a plus under root into under root of a. Then we have under root of a into under root of a into under root of a, something like this, which is nothing but a to the power x. It will have some power of a, right? This overall expression, when solved, will have some power of a. Similarly, we have under root of b, then 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 under root of b. This is b to the power x, because the powers are same only, no? powers are same only. Eventually, once I solve it, it will become a to the power something. That something I have taken as x. And this b will eventually solve down to b to the power something. That something is x. So this is how much log a to power x. And this is log b to power x. Now this x will come out according to property number 9. And this x will also come out according to property number 10. So what we have log a to the base b, and this x is here and this x is here. So this is getting cancelled. Log a to the base b, log a to the base b. This is what we have to work upon. And of course, this is the simplified format. Okay, moving forward. 3.5 is equal to 0.35 is equal to 1000. We have to find the value of 1 by x minus 1 by y. Okay. This is easy. So what we have? 3.5 to the power x is equal to 1000, which is 3.5 is equal to 1000 to the power 1 by x. And 0.35 to the power y is equal to 1000. So I will have 0.35 is equal to 10,000, 1000 to the power 1 by y. Now 3.5 upon 0.35 is 10,000 to the power 1 by x, and this is 1000 to the power 1 by y. So 3.5 upon 0.35 is 10. So this is 10. And this is 1000 to the power 1 by x minus 1 by y. Now let us try to apply this. What we have, b is equal to a to the power x, which is log b to the base a is equal to x. So log 10, instead of b we'll have 10 to the base a. A is what? 1000. And instead of x we have this 1 by x minus 1 by y. Okay, so this is log 10, and this is 10 cube, which is 3 will come out. So log 10 to the base 10, which is 1 by 3. Log 10 to the base 10 is 1. So 1 by x minus 1 by y is equal to 1 by 3. Simple as it. If x, y, z is equal to 1, find the value of, okay, find the value of this. Okay, very easy. Now, x, y, z is equal to 1. Can I write it like this? 1 upon log y to the base x and log z to the base x plus log z to the base x. Okay, yes, can be done. Okay, this is 1 upon log z to the base y and log x to the base y, and similarly 1 upon log x to the base z into log y to the base z. Now what we have? 1 upon log z to the base x. Okay, x, y, z we have. Okay. Okay. Yes, we can write it something like this. It will become log y to the base x, log z to the base x, and then this is log x to the base x. Now I'll expand only this. I'll expand only this term and then explain you what will come in these two terms. So log x to the base x is 1. Log x to the base x is 1, and I can multiply anything by 1. Now what I have? 1 upon log x to the base log x upon log x, I can write it like this, into log y upon log x, I can write this as well, into log z upon log x. We can write it like this in this fashion. What will happen? Log x whole cube. And this log x, log x, log x whole cube upon log x into log y into log z. We'll have something like this. Similarly, I can write this term in this format. And what we have? X in the denominator, so which became log x cube. So this will become log x log y cube to the base log x log y log z. And then this z will come up, will become log z cube to the base log x log y log z. Now, how much will this come out to be? Let us try to find this out. There is one property which you need to remember. So the property says a cube plus, I'm just writing down this property, a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c, a plus b plus c, in bracket a square plus b square plus c square minus ab minus ac minus bc. Okay. So this is the property which we have to apply over here. This is the property which we have to apply over here. So how can I write this down? This is log x cube plus log y cube plus log z cube upon log x into log y into log z. Okay, we have to apply this over here. Now I'm erasing everything else and just keeping this step. And you have to pause the video and write down it. So what we have, now let us say log x is equal to a, log y is equal to b, and log z is equal to c. Now log y. Now what will be a plus b plus c? A plus b plus c. This is your a plus b plus c. No? So a plus b plus c will be log x plus log y plus log z, which is nothing but log x y z, which is m plus n. So m plus n, it becomes m into n. So similarly, it will become x y z, which is log x y z is what? Nothing but 1 to the base anything. To the base anything will become log 1 is 0. Log 1 is 0. Okay, so log 1 is 0. So this is 0. So your right hand side has become 0. Now what you have? A cube plus b cube plus c cube minus 3abc equal to 0, which is a cube plus b cube plus c cube is equal to 3abc, which is a cube plus b cube plus c cube upon abc is equal to 3. Now what is a cube? Log x cube, no? Which is here log x is whole cube. What is b cube? Log y is whole cube. And what is c cube? That is log z's whole cube upon log x, log y, log z is what? A, B, C. Log x, log y, log z. It is nothing but A, B, C. which is equal to 3. So overall, this expression boils down to 3 only. Okay, this is how you need to solve it. Moving forward, which is greater, log 8 to the base 7 or log 7 to the base 8? It is very easy. Log 8 to the base 7, log 7 to the base 7, and log 8 to the base 7. Which is greater? This is greater. So log 8 to the base 7 is greater than 1. So this is greater than 1. And then log 7 to the base 8, it will be less than log 8 to the base 8. It will be less than log 8 to the base 8. Means log 7 to the base 8 is less than 1. So this value is less than 1. So obviously this value is greater because log 8 to the base 7 is greater than 1. Which is greater, log 4 to the base 1 by 3 and log 6 to the base 1 by 3. Now this is a very common mistake many students will do. Let us say if I have log 10 to the base a and log 12 to the base a, we say that log this value is greater. Okay, we say that this value is greater. But now what we have, log 4 to the base 1 by 3 and this is log 6 to the base 1 by 3. How will I write it? Log 4 to the base 10 upon log 1 by 3 to the base 10 and then log 6 to the base 10 and this is log 1 by 3 to the base 10. Now this is between 0 and 1 and when x is between 0 and 1, log takes negative value. So this is going to be a negative value. Similarly, this is also going to be a negative value. Okay, these two are your negative values. Now that these two are your negative values, now that these two are your negative values, this log 4 will be greater than log 6. Generally, log 4 is less than log 6. Okay, but now when I convert it into negative, when I multiply it by negative, this sign will change and this will be greater. This sign will change and this will be greater. So log 4 to the base 1 by 3 will be greater than log 6 to the base 1 by 3. This value is greater. Okay, this value is greater. Next, find the interval that log 13 to the base 3. Find the interval that log 13 to the base 3 lies in. Okay, this is again easy. Log 13 to the base 3. It will be less than log 27 to the base 3 and it will be greater than log 9 to the base 3. Now this is log 3 to the power 3 to the base 3 and this is log 3 to the power 2 to the base 3 and here we have log 13 to the base 3. Now this 3 will come out, this 2 will also come out. So log 13 to the base 3 will lie in this range. It will lie in this range of 2 to 3. It will lie in this range of 2 to 3. Now try to understand what we are doing here. Find the number of digits. So 45 to the power 150 will have a lot of digits, right? We have to find the number of digits and we have been provided with this. What do we do? Try to understand this, what I am doing. This is log 45 to the power 150 to the base 10. This is what I am doing. What I have done, I have just taken the log of this value. This 150 will come out using this property. This 150 will come out using this property, property number 9. And this will be log 45 to the base 10. I am just finding out the value of this, which is 150 into log 9 into 5, right? That is 3 square into 5 to the base 10, which is 150 into log 3 square to the base 10 plus log 5 to the base 10 plus log 5 to the base 10, which is 150 into 2 log 3 to the base 10 plus log 5 to the base 10 which is 150 into 2 into log 3 to the base 10 is how much? 0.4771. 0.4771 plus log 5 to the base 10 is how much? 0.6990. 0.6990. What is this? 150 into 0.4771 will be 47's double is 94 and 71's double is 142. So 0.9542 something like that. Okay, let us try to multiply 4771 into 2. This is 2, this is 4, this is 1, this is 5, this is 1. 954, 0.954 plus 0.6990, which is 150 into, this is how much? Base is 0, then this is 2, this is how much? This is how much? 13 1 carry, this is 15 1 carry, this is 6 1 carry to 1.6532. Now, which is 15 into 16.532. Now 16.53 into 15. I am doing this. So this is 5, this is 4, this is 45, this is 9, this is 4, this is 94, 9, this is 244.95. Somewhere in that range. 244.95, somewhere in that range. So this value is coming out as 244.95. So what I am trying to say, now let us try to understand the logic behind this. We have just done the process till here. Now let us try to understand the logic behind this. What I am saying, log 45 to the power 150 to the base 10 is nothing but 244.95. Now if I apply this formula, in reverse format, if I apply this formula in reverse format, log b to the base a, it's x, which is a to the power x, a to the power x, a to the power 244.95 will be equal to b. B is what? 45 to the power 150. 45 to the power 150. Now, what is happening? I am saying that 45 to the power 150, 45 to the power 150 is equal to 10 to the power 244, is equal to 10 to the power 244. Now, how many digits will be there in 10 to the power 244? Let us try to understand that. 10 to the power 2 is 100, so number of digits are 3. Number of digits are 2 plus 1. 10 to the power 3 is 1000. So, when I have power as 3, number of digits are 3 plus 1, 4. Okay, 10 to the power 5 is 100,000. Number of digits are 6, right? So which is 5 plus 1. So 10 to the power 244, number of digits will be how much? Number of digits will be 245. Why? Because it will be 244 plus 1. Okay. So number of digits in 10 to the power 244 is 245. Then the number of digits in 45 to the power 150 will also be 245. This will also be 245. Now you will be saying that 45 to the power 150 will not have only ones and zeros. No, it will not have. But then other digits are taken care by 0.95. The other digits are taken care by 0.95. Okay. So this is the process which we follow while finding out the number of digits. So to find out the number of digits, what we do, we take the log. We take the log of that given value. We take the log of that given value and then we try to solve it and we try to find out the base or we find out the value of that log. To find out the value of the log, such helping numbers will be provided to you in the question. Once you get those helping numbers and everything is provided, you find out this value, which means number of digits in the log or number of digits in the given word will be this 244 plus 1, that is 245. You just have to do this. You just have to do this. 244 plus 1, which is 245. Okay. Next. How many zeros? How many zeros are there between the decimal point and the first significant digit of first significant digit in 1 by 9 to the power 200? What we will do? We will just find out log 1 by 9 to the power 200 with base 10. With base 10. Now, what are they asking us, or what are they trying to get out of us? It is that 1 by 9 to the power 200 will be 0.0000000 up to some significant digit, let us say 4. Hai. So how many zeros are there? We want to find this out. So again, the process is similar. Again, the process is similar. We take log of the given value 1 by 9 to the power 200, and here the base is 10, which is log of 3 to the power minus 2 whole to the power 200, and the base is 10, which is log of 3 to the power minus 400 whole to, and the base is 10, and this is minus 400 log of 3 to the base 10, log of 3 to the base 10. Now what we have, minus 400 into 0.4771. 0.4771. Now 47, which is minus 4 into 47.71. Okay, so 47.71 multiplied by 4. So this is 4, this is 8, this is 2, this is 8, this is 3, this is 12, this is 50. So 150.84. So minus 150.84. So what I'm trying to say here is, log 1 by 9 to the power 200 with base 10 is equal to minus 150.84. And it is minus 150.84. Okay, minus 150.84. If I apply this formula over here, a to the power x, so log b to the base a is equal to x. So a to the power x is equal to b. So a to the power x is 10 to the power minus 150.84 is equal to b, which is 1 by 9 to the power 200. 1 by 9 to the power 200. Okay, 1 by 9 to the power 200. Means how many zeros are there here and how many zeros are there here, or how many zeros are there between the significant digit, between the first significant digit and this is, let us try to find that out. So how many zeros are there between the decimal point and the first significant digit? So if it is 10 to the power minus 3, how do we write it? 0.001. So number of zeros before the first significant digit is 2. What is this 2? It is 3 minus 1. This 3 minus 1. Let us say if I have 10 to the power minus 5, it will be 0.00001. Okay. So how many zeros before the first significant digit? 4. 4 is what? This 5 minus 1. So how many zeros before the first significant digit? It will be 150 minus 1. That is 149. That is 149. Now you don't have to do anything of this. This is just for the explanation. This part is just for the explanation. As soon as you get minus 150, so how many zeros are there between the decimal point and the first significant digit? So that is 149 zeros are there. Okay. Next, let us try to solve this. Log 2 is given, log 3 is given. We have to find out the number of digits in 6 to the power 7. Very easy. Log 6 to the power 17, which is 17 log 6. What we are doing, we are just taking the log of this value. There, 17 is out, log 6 to the base 10, which is 17 into log 3 into 2 to the base 10, which is 17 into log 3 plus log 2, and this is base 10, which is 17 into log 3 is how much? 0.4771, and log 2 is how much? 0.3010, 0.3010, which is 17 into, this is how much? 1, this is 8, this is 7, this is 7, 0.7781. So 0.7781 into 17, we have to do to 7781 into 17. This is 17 ones are 17, 1 carry 17, 8s are 136 plus 1, 137. So 13 carry 17 ones are 17 plus 13, 30. So 3 carry 17 sevens are 17 sevens are 119 plus 3. 119 plus 3 is 122. So these, then we have to add 4 points as well. So this is 12.2077. From here only we can directly say that number of digits are going to be 12 plus 1, that is 30. Don't try to get too much into the logic. Just understand that number of digits are going to be 12 plus 1, that is 30. Now the last question of logarithm, which is number of zeros coming immediately after the decimal point in the value, this 0.2 to the power 25. So how many? And this is log 2 to the base 10. Okay. Now what I will do, number of zeros coming immediately after the decimal point in this value. Okay. So what we will do, we will take log of 0.2 to the power 25. And here the base is 10. Now this 25 will come out log 0.2 to the base 10. This is 25, which is log 2 by 10 to the base 10, which is 25. This is log 2 to the base 10 minus log 10 to the base 10. Yes or no? 2 by 10 is nothing but log 2 minus log 10, which is 25 into log 2 is how much? 0.301 minus log, this is 1 only, no, direct. Now 1 minus 30, so that is 0.1 minus 0.301. This is 9. This is 9. This is 6. 0.699. So that is 25 into 0.699. So 25 into 0.699, let us try to do it. And this is going to be a negative value because 0.301 minus 1 we have done. So that is 25 into minus 0.699. So 699 into 25. 25 nines are 225, 22 carry. 25 nines are 225 plus 22 is 247. 24 carry. 25 6 are 150 plus 24 is 174. We have to add 3 points. So that is 17.475, and that too negative. Now, number of zeros before the first significant digit. Number of zeros before the first significant digit is going to be, number of zeros before the first significant digit is going to be 16. How do we do it? 70 minus 1. Now there might be a question, at which position after the decimal point, where is the first significant digit? Then that will be 70, right? After the decimal point, where will you have the first decimal point? That will be 70, or first significant digit, that will be 70 and not 60. So you'll have to find out, or you will have to read the question properly. What are they asking? If they are asking number of zeros between decimal point and first significant point, first significant digit, then 16 is the answer. And if they are asking after decimal point, when is the first significant digit coming, then 17 will be the answer. Okay. So this is what we had in logarithm. If you have any query, you can connect with us on any one of these two given numbers. Thank you so much. Jai.